Hello, my name's Mike Parkman and I'm going to give a quick demonstration of a third-year engineering project I've been working on for a class called Machines and Automatic Control. So the project is called a closed-loop PI speed regulator, and basically what it does is it regulates the speed of the fan, so if I try to stop the fan with my fingers, it can overcompensate for that and speed the rotor up to keep it running at a constant speed. So I'll just give a quick overview of the circuit. So I got a DC motor here. I have various resistors. I got LEDs. They all kind of indicate different things. This blue one indicates what mode I'm in, either fixed PWM mode or automatic control mode. This yellow light demonstrates the PWM running through the circuit, and this white light shows the back EMF generated by the motor. And you can see that that white light is connected in parallel with the motor. A couple other things I got going on here is this potentiometer, and I use that to switch between the two modes. So when it's all the way to the left, it's in automatic control mode, and all the way to the right, it's in fixed PWM mode. And then I also have this capacitor here, and the capacitor smooths out the voltage values and allows me to do some calculations in the code I have written here. And I'm not really going to get into the code, but the one important point I will talk about is this here, this E0SP. So that's the set point of 1.5 volts. That means that if I set it to 1.5, this speed controller is going to use the PI, which stands for proportional gain and integration, and it's going to use those two math functions to make sure that this fan blade is spinning in a way that's going to create that 1.5 volts. So I'll give you a demonstration of the device working. Plug it in to get some power to it. So the blue light's on, which indicates it's in automatic control mode. So I'm going to change it to fixed PWM. So in fixed PWM mode, it's spinning with a PWM of 85, and that doesn't change. So even if I touch the fan blades, the PWM stays 85, and it won't try to overcompensate for the resistance of my finger. So I can print some of the important values to my other laptop screen here. I'll quickly go over what a couple of these mean. So we have V1, V2, and V3. Those are voltages at different points in the circuit. IM is the current that runs through the motor. E0 is the voltage created by the motor, and that's in fixed PWM mode. It just like the PWM stays 85, so the E0 is not what I want it to be, which is the 1.5. So because I've set it at 1.5, it's spinning at 0.8. That's an error of 0.7. And this is a good time to say that if the error is positive, that means that the fan blade is spinning slower than I want it to be. But when the error is negative, that means the fan blade is spinning faster. So now I'm going to switch it into automatic control mode and show you when I try to stop the motor, it'll increase the PWM on its own to try to overcompensate for the resistance caused by my finger. So showing you this here, now we can see that the PWM's changing quite often to try to match up this E0 with the set point. And I'll give one last demonstration of holding my finger on the fan blade. You can see that the PWM's changing. The air is kind of bouncing around around 0. I have negative and positive numbers. And yeah, that's my project. Thanks for watching.